Okay, now, so let's move to linear equation, the second equation that we're going to learn throughout this chapter 1. So, first of all, we need to identify the linear equation. So, how can we know that we have linear equation? We have a linear equation if we have in the form of this one. A as a function of x, it can be a function of x, or it can be a constant. Also, this also goes to B and C. Okay, A, B, and C can be a function of x, or it can be just a constant. Okay, when you have A dy dx plus B y plus C, so that we call it as you have a linear equation. Okay, so what you need to do, okay, in order to solve for linear equation is, when you have in the form of A, okay, dy dx or ay prime, okay, plus by equals to c, again I remind you that we can have A, B, and C. It can be constant, or it can be a function of x. Okay, only a function of x. A, B, or C is in the function of y or other than x, so that you have a non-linear equation. So now we focus on linear equation only. Okay, so when you have a linear equation, the first step that you need to do is you need to divide both sides of the equation by A, where what I can say is you must make sure that the coefficient of your dy dx is 1 only, so that you have no more A here. Okay, divide both sides of the equation by A, so you have divide by A, and divide by A, so that you have dy dx plus b over ay equals to c over a. And this equation can be simplified in the form of dy dx, okay, plus b over a here, we call it as p. P as a function of x, or p just a constant. P times y equals to c over a here, we can define it as q. I just rename it as q, so that you have the specific equation of linear equation here. Okay, so after you simplify the equation, what you need to do next is you need to find out the integrating factor. So what is the integrating factor? Integrating factor is what we call it as the next to your y. Okay, for example, this one. So this is your the one that we want to find the integrating factor. Okay, so the integrating factor can be obtained by taking, we name it as not p. Okay, this one is rho. Okay, you have rho equals to exponent, integrate your p with respect to x. Okay, so find your p here, plug in your p here. If you have negative 2y equals to something else here, so that you have p is negative 2, okay, because the standard equation is plus, but here you have negative. So in order to match with your standard equation, so you have 2 plus, and then you have negative 2 times y, so negative times positive, so that you have negative sign here, so that your p is negative 2 instead of 2. Okay, so this is what we call as integrating factor. After you find your integrating factor, just follow the step of solution here. I don't want to discuss much on the step of solution. You can find in your PDF notes, but I will show you the step of solution throughout the exercise here, okay, or throughout the example. Okay, so now let's solve for the differential equation here. Look, we have A, which is your x. Okay, a is a function of x, which is x. Okay, a dy dx plus by, your b is 2, equals to 5x cubed. Okay, so this is obviously a linear equation. I know this is a linear equation because we already know the general form of linear equation here. Okay, so this is how we determine, or we identify, okay, we screen. Okay, the initial step is we try to screen. Okay, you go screening that you have a linear equation, and then we try to solve it. In order to solve, again, I mentioned earlier that you need to make sure that the coefficient of dy dx is just 1, so that you need to divide both sides of the equation by your a. Your a here is x, so that we have dy dx equals to 2 over x y. Sorry, this is not equals, so this is this is plus sign, plus 2 over xy equals to your right hand side, you have 5x cubed over x, so that you have 5x squared. Okay, so next step is we need to find out our integrating factor. So integrating factor is given by rho equals to exponent, integrate your p. So what is your p? So this one is dy dx plus py equals to q, right? So that our p is 2 over x. So I just put it here. Y. Sorry. No y. Okay. You just put p and then integrate with respect to x. Okay. So I would like to solve for my integrating factor first. So rho equals to exponent. Okay. I have 2 over x. 2 is just a constant. I take out 2 so that I have 1 over x dx. Do you agree? Okay, so we have exponent 2 is just a constant, so we have 2. Then I have integrate 1 over x so that I have natural log x. And during our secondary school, we already learned the indices, okay, index. Okay, so that we have exponent, natural logs, x square, where these two can be brought to your x, okay, so that you have e natural log x square, and we know based on our knowledge, exponent natural log can be cancelled out so that you have x square. Okay, so this is our integrating factor. After you have the integrating factor, what you need to do next is you need to multiply. Okay, you need to multiply your integrating factor to both sides of your equation that you already reduced in the form of dy dx plus py equals to q. Okay, not this one, but this one. Okay, so I just highlight this equation. Okay, so multiply both sides of the equation by x square so that I have x square dy dx is y prime. Okay, I just write this as y prime. Okay, plus 2 over x times x square so that I have 2x, agree? So I have y, and then I have 5x squared times x squared so that I have 5x to the 4. Okay, after I multiply, then what I need to do next is I try to simplify both sides of the equation. Actually, the next step is we try to integrate both sides of the equation. But it is easier for us if we can simplify the equation first. Okay, so in order to simplify the equation, we just simplify the left hand side of the equation. So how can we do this? Okay, note that y prime is dy dx. Okay, so what we need to do is I just put rho y here, and then I have 5x to the 4, just remain the same thing on our right hand side, but the left hand side is we need to simplify. Okay, I just put rho y. So what is rho just now? Rho is actually x square, so that I have y. Okay, so I have simplified left hand side, I just put rho y, rho is x square, and then my right hand side is 5x square. Okay, and rho y need to differentiate, okay, your rho y, so I put it like this. Okay, the rationale is when you try to differentiate this equation, okay, try to apply product rule here. Remain your x square, differentiate your x, you will have this one, x square dy dx, and then remain your y, differentiate x square, then you have 2xy. Okay, so actually this is the simplification of this one. Alright, so after I simplify both sides of the equation, so now I can simply integrate both sides of the equation. Okay, so now I want to integrate this equation with respect to x. Okay, integrate with respect to x both sides of the equation, so that what I can say that integrate and differentiate something, you can cancel out so that we have x square y, just remain x square y, and then my right hand side I have to integrate, so that I just direct integration, so that I have 5x to the 5 over 5, so this one is x5, and then plus a constant c. Okay, if I just want to have only y on my left, so that I can simplify my left hand side here, and then I have x cubed plus c over x square, or c times x to the power of -2. So that this is my general. So this is the steps of solution. Okay, so the first thing is identify the type of equation. So I have linear equation, and then try to reduce the equation in the form of simplified version. Okay, dy dx plus py equals to q. Okay, and then find the integrating factor. After you get the integrating factor, multiply the integrating factor in that you simplified just now, and then try to simplify the left hand side while your right hand side remain unchanged here. Okay, simplify the left hand side, you just put rho y, and then you need to differentiate with respect your right hand side of your equation remain unchanged. After you do that process, and then you need to integrate both sides of the equation with respect to x, and then you get the general solution. We are very lucky for this example because of the right hand side of the equation just involve only direct integration. Okay, for your information, probably you will deal with more difficult integration, which requires the technique of substitution, or it can be partial fraction and the other related techniques of integration. So let's talk about the second example 2.9 during our class. So that is the end of linear equation.